So lipid transport. Remember, lipids are fats. Okay, and fats are insoluble. So you need something called lipoproteins to carry these water-insoluble fats around the bloodstream. And lipoproteins are complexes of cholesterol. Cholesterol, triglycerides, and phospholipids. So it carries all those around. Those are all types of lipids. And there are 5 classes of lipoproteins. So there's 5 different flavors of lipoproteins. And in order of increasing density, there's going to be something called a very low density lipoprotein, VLDL. So increasing density, low density, high density. Then there's intermediate density lipoprotein. Then we have low density lipoprotein. So remember, it's kind of a weird one because intermediate is actually lower density than low density lipoprotein. So you want to keep that in mind. Finally, we have high density lipoprotein. Now, so we have all these different types of lipoproteins carrying on our fats. There are also something called apoproteins. These are support molecules. They're part of the lipoprotein complex. You can find them on the lipoprotein, and they have different functions. Some of them function to direct lipoprotein to receptors. So, for example, apoprotein E will do that, and then others will catalyze enzymatic reactions. So we're going to see later that ApoC2 does some of that. Okay, now there are 2 pathways for lipid transport in the body. There's an exogenous and an endogenous. So exogenous means that it's fat from the outside. It's fat from outside the body that you put into your mouth and you eat, and that's how you get those fats. Then there's an endogenous pathway because we have fats made in our liver as well. So let's talk about the exogenous first. So remember, this is fat from the outside. So you have a nice fat In-N-Out burger. You eat that In-N-Out, you digest that juicy patty, goes into your intestine. It's dietary fat. It's absorbed by your intestine, and then it's packaged into something called chylomicrons. Okay. Chylomicrons are they're pretty similar. They're pretty much lipoproteins. They're complexes of fat and triglycerides, and then this is absorbed through the lymphatics. Remember, lymphatics are where the fat goes because it's liquid and soluble. And then this chylomicron will receive, remember we talked about apoproteins, it's going to receive apoprotein C2 and apoprotein E from the HDL. HDL is pretty much a reservoir for all these apoproteins. So the HDL holds a lot of them, and when they're needed, they transfer them to the necessary molecules. So in this case, in the exogenous pathway, it gets transferred to chylomicrons. So this is ApoE, and this is ApoC2. Okay. So now C2, remember we said C2 is important for catalyzing enzymatic reactions. Well, the enzyme it's important for is lipoprotein lipase. So lipoprotein lipase breaks down triglycerides. It's going to turn that triglyceride into a free fatty acid. And we see lipoprotein lipase on the surface of adipose and muscle tissue. So when it breaks it down, you're going to get that free fatty acid. It's going to be taken in by the muscle for energy and the adipose tissue for storage. Let me repeat that again. Let's just go from the beginning. You absorb you eat that dietary fat, absorbed in the intestine. It's packaged into chylomicrons in the exogenous pathway. Chylomicron receives apoproteins that enable its function. Apoprotein C2 will catalyze the enzymatic reaction of lipoprotein lipase, which will take a triglyceride and break it down into free fatty acids. And this is done at the surface of adipose and muscle tissue. And this free fatty acid can then be used for energy. It'll be either used for energy by the muscles or stored as energy. Then we've broken down a lot of triglycerides. So now you see we have a chylomicron remnant. It's smaller. There's less triglycerides in there. And it still has the ApoE apoprotein. That's going to direct it to the ApoE receptor in the liver. And then it's going to bind to the liver, and it's going to be removed from circulation. So that is our exogenous pathway. It's pretty simple if you think about it. Now, our next pathway is the endogenous pathway. This is from lipids made by the liver. Sorry about that. So now we focus our attention on number 5, where we make the liver packages cholesterol and triglyceride into VLDL particles. Remember, that's very low density lipoproteins. This lipoprotein, well, again, it's similar to the chylomicrons. It's going to receive apoproteins from HDL. Ignore this, but it's going to get apoprotein C2. It's the same ones as before, apoprotein E. And the same idea as before, lipoprotein lipase will take that VLDL, it's going to break down triglycerides. Remember what it does turn it into? It turns into free fatty acids. And this is done, remember, at the muscle and at the adipose tissue. And that's energy is going to be used by those two types of tissue. So we just broke down VLDL. We took out some of its triglycerides. So now it's smaller, it's more dense. So now it is intermediate density lipoprotein, ILD. Now there's 2 fates for ILD. It can either be brought straight back to the liver with the ApoE receptor, and that happens to about half of it, or it can be taken to the liver and then further processed, and when you process it more, you get rid of more triglycerides. It becomes even smaller, becomes more dense, so then that becomes a LDL, low density lipoprotein. And that is sent out by the liver into the peripheral circulation. And this is absorbed by peripheral non-hepatic tissue. This is important because LDL is really important it's taken up by blood vessels, and it can cause that atherosclerotic plaque that we talked about. Remember that atherosclerotic plaque? A blood vessel takes up all this LDL and various other things. We're going to talk about that later. And it thickens, and it's going to block up that blood vessel. So this is all important. I want to recap this again. This endogenous pathway in a lot of ways is very similar. The key difference is that we start out with VLDL and not chylomicrons. Otherwise, it's very same. Same thing. You get the HDL transfer. You get the lipoprotein lipase. And then this turns into ILD, intermediate density lipoprotein. And the key difference here is that it can either be brought back to the liver to be breaking down again, just like the chylomicrons, or it can be further processed into LDL. This is the key difference here, and the LDL can be sent out into the bloodstream and then cause some problems, such as atherosclerotic plaques. Couple other things I want to mention is function. Let's clear this page a little bit. So I just talked a lot about this, but what do we even use cholesterol for? What is it needed for? Cholesterol, it's important for our cell membranes. It's important for the integrity of cell membranes. It's also needed to make a few other things like bile acids, steroids, vitamin D. Bile acid, steroid, what's the last one? Vitamin D. Okay, and so remember, exogenous pathway and chylomicrons. Everything else is endogenous pathway. VLDL, VLDL, IDL. Remember, IDL is less dense than low density lipoprotein, which to me doesn't make sense. Okay. And then overall general concepts, HDL helps bring back cholesterol from the periphery. Remember, it gives all the lipoproteins that ApoE, which sends them back to the liver. So this is good in cholesterol. Okay, it lowers the cholesterol by giving them ApoE proteins, apoproteins, to send them back to the liver. And LDL is the bad one because it's taking all that cholesterol from the liver and then it's sending it onto the periphery. And remember, it can lead to atherosclerosis. All right, so that's it for our lipid transport lecture.